we left off last time. So we're talking about loops. We did cool things. We put loops within loops, right? We drew pretty pictures. We learned how to solve fancy problems and think about things. So there's one last thing I want to show you. This is going to help you for your future lab. Here is a cool idea. Let's make a graphing calculator of a program. Okay, that'll be nice. So I'm going to graph a circle for us on the terminal. That'll be really, really cool, I think. And we're just going to use the terminal as our window into our graph. And here's kind of the idea. This is my goal eventually. Like, you open up your terminal, by default, it's like, looks kind of like this. It's got this much room for a window, for a graph to be displayed. And kind of like smack dab in the middle, what I want to do, with enough spaces and moving around, is I would like to draw as perfect of a circle as I can with just star characters. Something like this. I can't think and write at the same time, so here. This is like a circle, right? That is what I would like to do. Pretend all of these dots are really star characters. Okay, that's what I'd like to do. All right? Because honestly, all this is drawn a bunch of characters. There's a grid of characters. Just sometimes it's a space, sometimes it's a star. We know how to do that with boxes, right? So when you open up your terminal for the first time, by default, it should be 80 characters wide by 24 high. So let's make that our box. All right, let's make a width equals less, so you can still see the next terminal prompt. Let's make a width 78 and then a height 24 box. Let's start with just a box of stars, right? And we'll go from there. This will eventually turn into a really cool graph. All right, I promise. So let's start with that, graph.pdp. All right, so for int I equals 0, I is less than what? We're going, how many lines do we have, right? Because the outer loop deals with lines. We got 24 lines, 24, I plus, and then for int j equals 0, j is less than, how many columns per line? 78. 78, j plus plus. And then all along every line, I'd like to draw a star, a single star character. And then after 78 stars, I want to break the line. So I got a 24 by 78 box. Okay, that's stars. Graph. This will be hard to show you the entire program as well as the code at the same time. So like there it is. Here's the answer. If I zoom out a little bit, you can see it all. That is a 78 by 24 box. Yeah, made with this code. Any questions about that? That's review. You kind of see how I got that? So, all right, that's a box. Well, I get this pretty picture, and that's almost a graph. Well, let's think about coordinates, right? There's x coordinates and y coordinates. You kind of see in the loop, right, that your I variable, your outer loop variable, is dealing with which line you're on. That's pretty much like y, isn't it? It's y in the graph. So we should change I to y. And then j is going across the line. That's like x. So I should be y and j should be x, really. Huh. All right, let's do that. Sorry, y. And j should be x. Cool. No difference, right? If I recompile and rerun this program, nothing's changed. Still a box of stars, just as we left. But I've used a different variable now to kind of indicate what I want to have happen, because we're about to graph. And then, kind of the goal, right, is to have 0, 0 in the center, so you can draw, like, center all your graphing stuff. So I would like x equals 0, y equals 0 to be smack in the middle of my little box, all right? How can I do that? How could I do that? I have to change the way it's ranging right now, because it's going from 0 to 24 and 0 to 78, like that. That's too big, right? In the middle is not. It's like half of 78 and 12, right? So let's fix that. If I make y, like I want y equals 0 on this line, which kind of means, like, if I have 24 lines total, I got kind of split in half. Like this should be y equals 12. This should be y equals like negative 11. Got to use up 24 still. Does that kind of make sense? Like I can change it to range in that way. And then, like, if I want x equals 0 to be right in the middle there, then I got 78 characters wide. I got to kind of like shift everything over. This can be on this side, like x can be negative 38. Over here, x can be positive 39. That's still going to give me 78 characters. But now, 0's in the middle of that. 0's in the middle of that. Does that make sense? That's pretty nice. And so let me change how these things range. So y, we're drawing the first characters on the top here first. So y needs to start at 12 and make its way down to negative 11. So you see that? That's important. So y should start at, let's see, negative 12 and make its way down to negative 11. So I need to change the way I do this. Well, it's greater than or equal to negative 11. Yeah. And y minus minus. Cool. And then x can still range from left to right. But if I want x to be 0 in the middle, I better start it at negative 38 and end it at positive 39. So negative 38, go all the way to positive 39, x plus plus. All right, I've just changed the range. If I recompile and rerun this, still nothing's changed. Oops. What have I done wrong? What's that? Oh yeah, thank you. Thank you, yeah. I confused myself. There were no values within that range. There it goes. Thank you. So there, we're back to the same thing. Another question? Oh yeah, thank you. Yeah, thank you. Oh, am I? I am. Thanks. If you don't see me click it, yeah, yell at me. Thank you. So, yeah, we still got the same thing. Are we still clear? Like, this is the same code. It's still going to print the same stuff. I've just changed the way the variables range. It's the only difference. Because now I do have 0, 0 in the middle, and I can prove that to you. I can draw a little plus sign, like I kind of put here. This can be the axes meeting. Like, if I'm at 0, 0, I'll draw a plus sign. Watch. So usually I'm drawing a star, but if I'm 0, 0, if, let's see, x equals 0 and y equals 0, then instead of a star, otherwise I'll draw a star, instead of a star I'll draw a space. Or sorry, I'm thinking ahead too far. Instead of a star I'll draw a plus. So that's the axes meeting, all right? Interesting. So usually I'm drawing a star, but in this one case, when both of those are that, I'll draw a plus, and I will prove to you that's in the middle now, due to the way that I've changed the ranges. Boop. I gotta zoom out. Needle in a haystack, do you see it? Yeah. That's nice. That's real nice. Any questions about that? We got some nice code here that draws essentially almost a graph. We're getting there. Okay. So that's the ranging that we've done, and now I want to print a circle somehow. I want stars around a circle, a graph of a circle. We know the equation for a circle, right? It's x squared plus y squared equals r squared with a good, let's like draw a radius 10 circle or something. We just kind of need to, whenever this works out, check, right? Is our current x squared plus our current y squared equal to 10 squared, or whatever radius graph that I want to draw? Like, that'll just be another if statement. Does that kind of make sense? That's how it'll work. So yeah, let's go further into that, because that's gonna lead to some interesting facts. So again, my goal is eventually to have empty space, the axes meeting, and then a circle out of stars. All right, that's my goal. So let's graph x squared plus y squared equals 10 squared. And to do that, we have to like figure out which coordinates are part of my circle right now. Kind of like it's not quite this that's going to work out. We want to solve for y essentially. Let me show that to you. So I have to figure out which coordinates are part of the circle, and for reasons, it will help us to always solve for y. Okay. So let's solve for y. Y is equal to, you gotta like take the square root, right? Move things over and take the square root. So it's like 10 squared minus x squared, and then you take the square root. That's kind of the answer. Then you have to do the plus or minus, right? Because you're taking the square root. So that is going to be the equation that we graph for silly reasons, because we only have whole number coordinates. So our goal is kind of like, if you give me, like, here's how you graph stuff, right? Give me an x, tell me which y corresponds to it. This is kind of how we do that. Like, plug in your x, tell me which y corresponds to that x. That's what we're doing. That's why we're solving for y. All right? That's our goal. So yeah, now that we have that equation, what we will do is, yeah, we'll just check is our current xy coordinate, because what are we doing? We're ranging over a bunch of different possible xy pairs, right? That's what nested loops do. We'll check if our current coordinate matches this equation, one or the other, the positive or negative version. All right, so we have a current xy. It needs to be plotted on our graph as a star. Xy needs to be plotted. What's true about x and y? If this is true about x and y, let's do like the top half. If y is equal, double equals, right, to the square root of 10 squared, there's the math library for that. I'm leaving some space for a reason. The square root of 10 squared, that's like 10 times 10, minus x squared, so that's x times x. And then it'll usually never be equal. All right, so kind of watch what's going to happen. It'll be true on the corners, right? This will be like 10, 0, 0, 10. Like then it'll add up to 100 perfectly. The square root will be exactly equal to 10. But I told you that you can never really check for doubles and equality. Because like what if your circle, right? A point of your circle is like right here. And there's no way that's a whole number, right? Our x's and our y's are only ranging between whole numbers. So I have to kind of like shove or nudge each x to the closest one. We'll get the corners just fine. We'll get the corners just fine. But it needs to be rounded, right? So like, for example, this point, this x point, the closest y, there's no way that's a whole number x, right? There's no way. Those are whole number x, y coordinates. So like, for this x, let's calculate the closest y to that point. So I can just round. If I round it all, do you see how that'll shove it to an integer? And then I can compare against all these things because I'm only ranging over integers. Okay? Yeah?
You also use like the function, right?
Yeah. That could totally work. That's just more writing for me. But you could totally use pow. So it's like for every x coordinate, I'd like to find the closest y coordinate. That's why we solve for y. Okay? That's the goal. That's how that's going to work. It's silly decimal issues. We can't use the original equation. That's why this one won't work. You have to like round one or the other. So we need to squish our decimal places onto our integer coordinates. Give me the closest one. Squish decimal places onto integer coordinates. And this is legitimately what's happening inside of your own graphing calculators if you own one. Like there's only so many pixels. It's got to shove like, do I put this pixel black or do I put this pixel black? It's got to find the closest one. It's never the perfect picture, right? It's always a little blurry. So yeah, that's what we're doing. And let's check. Let's do this now. We're ready. So okay. We got a bunch of options, right? Usually I just want empty space most of the time. Either the axes meeting or empty space, or if we're on the graph, we'll do a star. So right now, I just changed the star for a space. Now here's my blank slate with plus in the middle of everything. There used to be stars. And so now, up here, the very first thing I'll do is I'll check. Hey, is x and y, are they equal to just this? If so, this is the closest y for this x. It should be plotted on my graph. Okay? So is y equal to the rounded form? Oh, I need CMAT. Is it equal to the rounded form of the square root of 10 squared minus x squared? Oh gosh. Close it off, close it off, close it off. If so, it's on the graph, right? And this becomes an else. If so, it's totally on the graph there, and I will see out a star. Cool. So this will be on the graph. Okay? Axis meaning this is empty space. Dun dun dun. And there's my star. So there is most of the code. Let me zoom out a little bit. There's the end of it all. So that's the code so far. So what am I checking for each xy coordinate? I'm arranging over all these guys. If it's on the graph, plot the star. If it's the axes meeting at 0, 0, make a plus sign. Otherwise, if it's just empty space, if it's nothing I care about graphing, then just like move over to get ready for the next coordinate. Empty space, please. And that will give us the top half of a circle. Isn't it beautiful? So we gotta do the bottom half still, of course. So this was the top half of the circle. And so again, like for every x coordinate, we're trying to find the closest y coordinate using whole numbers only. That is, that we can use to graph as close as possible. So otherwise, if it's on the bottom part of the graph, that's the negative version, the negative square root. Let's see how that one is. That's most of this. There it goes. So I can do the rounded negative square root there. And this will be the bottom half of the circle. I still want to plot it as a star. All right. So that's the only change. And now, if I try again, I will have a beautiful circle printed. It's not perfectly round because I think you can imagine every character on the terminal is twice as tall as it is wide, so it's being stretched in that way. So you could account for that if you wanted to by like ranging your x slower, like 0.5s or something. So this is technically accurate if these were actual pixels. Any questions? Isn't this magical? I think it's really, really cool that we can do this now. And this was the code that did it. It's a lot to show you, though. Are there any questions about any of those steps and how they all fit together to give us a beautiful picture?
So why do you need to have y by itself?
Because I need to, it's always like, this is how we graph in like elementary school, right? You find for your x, what is the y on that graph? Where do I go to? You like draw a line through those things. So that's kind of what we're doing here. Like for my x's, what is the y that is the closest on my graph paper? That's kind of how we're doing it. We're rounding it because most likely the square root of something has decimals. It will never be exactly one of these. If I didn't round it, let's see what happens if I don't round it. I think that would help. If I forget to round, it will most likely never be exactly equal. Sometimes, but not always. You see how I'm missing some stars now? The other ones were decimals. And so, if we want those still there, just like shove those to the nearest whole number and then it will be equal to something. Yeah, good question. All right, I think that is all that I wanted to say about that. I hope we understand the process because I'm going to force you to do this on your next lab. It's going to be great. All right, so if we are good, please ask questions so that you know how to do it. But if we are good, I would like to move on to a different set of slides now. We'll get through a little bit of this today. So the next topic is arrays and vectors. We won't finish this today, but it's a useful topic to know. It's very, very helpful for us. All right. So here's the idea. I'm going to teach you two concepts. They're very, very similar. One is called arrays, one's called vectors. I'm going to teach you arrays first, but honestly, vectors are the cooler one. They're the one you're going to want to use most often after you learn about them. But arrays are like the simpler form. That's why we're learning them first. Okay. So in general, these slides are about holding things. Like we know how to hold stuff for later. We put them in variables. But what if we wanted to hold a bunch of stuff all at once? Do something like this. A big long table of things. I mean, we could do that with characters in a string, but what if I wanted to do the same with like ints? These will give us that ability, okay? So, yeah, after you learn about arrays, you can kind of forget about them until CSCI 41, honestly. Unless you're doing super low-level stuff and you need the memory savings or the time savings, or if you're doing multi-dimensional things, you can make 2D arrays, 3D arrays, and they're easier to use than the equivalent of vectors. Other than that, like vectors are always the better version to use. They're more helpful, okay? So, but still, I'm going to show you stuff that looks like this. We're going to start with arrays. All right, let's do it. So, the goal of both arrays and vectors is to hold a bunch of things of the same type. All right, that's the goal. So, like, here's our current problem. Like, if I told you to code this up, here's how you kind of would have had to code it up, right? If I ask the user for 50 numbers, I give you that problem. Please ask the user for 50 numbers and print out all of those numbers that are typed in order. This is the only way you could do it, right? You would have to make 50 separate int variables. Disgusting. And then you have to cin into each of them. You can't even use a loop because they have different names, right? We do not like that. We would like to have an easier way to solve this same problem, right? That does not require all this duplication, all this separate naming schemes. All right, so instead, enter arrays. An array is, okay, look it up in like your textbook. It's a variable that has a single name that holds a list of things, a whole bunch of things at once. They all have the same type, and you can get at each piece of it. All right, you can get at each piece that you put in. All right. So here is, I guess, more terms than I'll draw a picture. Every piece in an array is called an element. All right. And what I mean by directly accessible means you can go into any index just like you can for strings. Right? You can index into your array using the brackets. That's a new operator. Okay? So here is an example declaration of an array of ints. You kind of read it backwards. You say R is an array. The brackets mean array. It's an array of 7 integers. It's kind of all over the place. Right? So that's how you read it. You'll get used to it. So R is an array of 7 ints. That's quite nice. All right, so this is what it looks like in memory. It's a longer box, and it holds 7 things. That's capable of holding 7 integers. And they're all, just like normal ints, they're all set to garbage right now. You got 7 pieces of garbage that you can eventually fix, right? And the indices all start at 0, just like for strings. So 0, 1, 2, 3, 4, 5, and 6. You can access indices 0 through 6 of your array and put an int in each of them. Okay, that's what it's good for. So again, here's how you do it. To declare an array, you say the type of things you're storing, like int. You give a name for your array, just like a normal variable name. And between brackets, you can give the size of that array if you're ready. If you're ready with the size. Okay. So yeah, just by default, it's filled with garbage. So if you say int r of size 3, that's going to make an array that has 3 indices, capable of holding 3 ints, but right now it holds 3 garbage ints. 0, 1, and 2. All right. If you would like to put things in those pieces, in those elements, you can use this operation. You say the name of your array, and you use brackets again, and then you give an index that you want to go to, and then you can set that equal to something else. You can assign to it. So I can say r of 0, please become 1. Okay? And that'll replace the garbage with 1, and now you can get it back out, right? So that's going to index, indexes into r, and it sets the value there. And you can use the same syntax to like print it out. Just print out r of 0 now. Now it should show you 1. Is there a question? Yeah. No, this is just a variable. This is just, it could be anything. All right, but variables can have underscores in them. So yeah, that's how you change stuff. And if they're like you're ready at the start with things that you want to put in your array, you can declare it like this. Like int r of 3 equals braces. You give braces and the things you want to put in them. 1, 2, 3. So that'll fill it up immediately. So you can say something like this. Int r of size 3 equals braces, all the elements that I want to have there initially. 1, 2. So this is a declaration and an initialization. Okay? So that works. Alternatively, and then I'll fill in r with 1, 2, 3 at indices 0, 1, and 2. But honestly, because you're given 3 things, it's kind of obvious, and you don't need to tell C++ about it. You could use just empty things between the brackets. That would also work and be of size 3, because it's like you're given 3 things. It knows that's what you want. Okay. So yeah, it doesn't have to be an array of ints. It could be any type. It could be like an array of doubles, double A2 or something. Bracket equals a couple doubles. 3.14, 5.67. I don't know. And that would make an array A2, holding 2 doubles this time. Indices 0 and 1, 3.14, 5.67. Right? So I think that is what I wanted to say in words. Yeah. Questions about that before I give you a demo? I'm not quite sure what you're saying there. If you wanted 4 things, you would add a 4th thing in between the curly braces. Is that what you're asking? You have to say up front, though, like, I need it to be that size. Okay. Yeah, that's important. It needs to know its size at the very beginning, either implicitly like this or explicitly like this, or with the actual size there. Okay. So let's see here. Let's have a demo. Let's have a demo of printing out some stuff. Let's ask the user for 10 numbers. Let's do exactly this now. Let's ask the user for 10 numbers, and we'll go and print them all back out. And then we'll do some other things too. Okay? So I want 10 numbers from the user. Let's say they're integers. And I'd like to spit them right back out, please. So what I'm going to do is I'm going to declare an array, give it a name, I'll call it R again, of size 10. Does that make sense? I'm going to declare an array of size 10. Fill it in. So I like an array of size 10. Right now, they all hold garbage, every index. So R is an array of 10 ints. And because there's only 10 things, what are the valid indices I can use when I'm talking to my array? The valid indices I can access start at 0 always. They're 0 through 9. Okay, so remember that. Don't be off by 1. Two issues. Now I want to ask the user for 10 numbers, and I want to fill in this array. So right now it looks like this. It's R. It's got 10 things in it. 10 garbage things, though. It's got to be very long if I want to draw it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Indices 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And now I want to put stuff at each index, getting it from the user each time. So I'm going to loop, right? This is a nice thing. I want to get 10 numbers from the user and put them into R at each different index. We'll just go in order. So I will loop. This is another reason why we like to start our loop variables at 0. We're just used to doing this and filling in arrays. So I'll say int I equals 0, I is less than 10, I plus plus. Do you see how I is going to range over every possible index of R? That's a nice pattern to remember, okay? So I is going to get a chance at being every valid index of R, 0 through 9. And I, whichever one I'm working on right now, I is the current index of R that I'm trying to fill. So let's ask the user for one number and put it at R of I. R at index I. Right? Enter enter the next element. Please, user. And then we'll make space for it. Technically, this is not necessary, but I'm going to show you this way. Next element. And then we'll shove, now that I've got a value, into R of I, please make it next element. Okay? Does this kind of make sense? How this is going to fill up that array at each different element index with that new thing? Technically, I didn't need this extra variable. I could have just read into R of I, but like that's too much new knowledge, I think. So this is easier to think about. So yeah, after this loop is completed, I've asked the user 10 times. I've filled in all of the indices, and I's gone through all the right ones. Now, if I just do it all over again, if I go through that array once more, I can print all the values, right? That's what I want to do. Let's print all those values right back out. So I'll steal most of this code and change it around. So I would like to print out all the elements of R. And so, again, I want to range from 0 to 9. Those are the valid indices of R. We got 10 things, 10 spaces. And each time I don't want to fill anything, I just want to look at the value. See out R of I. Okay? Or let's print them all on the same line. So I'll print it with spaces between and then break the line at the very end after all that. Okay? So, well, let's compile and run. Oh, did I do something wrong? I think it showed me an error. Oh, no. All right, so here we are in the first loop. So we made space in memory for this array of 10 things. We're in the first loop, and I can start typing stuff. I don't know, 1, 2, 3, 4, 5. I'll be lazy. 6, 7, 8, 9, and 10. I'll fill in the last one. And then once that's done, the loop is complete. We go to this next one. It's going to see out each index of I with a space in between. Okay. Any questions about that? That's pretty nice. It's much better than making 10 separate int variables. I hope we agree. Okay. We good with that? So that's just printing. What's another thing that we can do? Now we've filled up our values. Like you can put whatever you want, but let's just pretend they were these 5, 6, 7, 8, 9, and 10. That's what I typed the first time at least. Let's get the sum of all the values that the user types, those 10 values. We kind of know how to do that already, right? So we want to start a sum variable out at 0, and then just keep on adding in all the things that I want to sum up. So like visit each index of R and bring it into the sum, add it into the sum. So sum should be 1 after that. Add in the 2, so now it's 3. Add in the 3, now it's 6. We can do that in a loop, can't we? That's going to be our goal. Add in the 4, now it's what, 10. And then just like keep bringing them all in. 5, the 6, the 7, the 8, the 9, the 10, until they're all in there. Okay. So that'll sum up those 10 values, whatever they were, and I will have that variable at my fingertips, and I can print it out. I can use it in a larger mathematical problem. We do whatever we want. But we got the 10 numbers. Now instead of printing them, or in addition to printing them, let's sum up everything. Let's sum all the elements of that array. So I want to loop again through the valid indices, and I want to visit them all and add them up into like a sum variable. So let's go through them all. Let's do for int j this time. J equals 0. J is less than 10. J plus plus, just to get practice with using different indices as a variable name. So every time I have a new index j, I want to go to R of j and like sum up the values that I see. So add that index into sum. Add the value there into sum. Okay. Does that make sense? So yeah, after I do that, I should have a sum that I can print out. And hopefully it all works out. So again, filling it up with those exact values. It doesn't matter. You can type whatever you want. I'll type those. And the sum of those, I happen to know that is in fact 55. So that is the right answer. Okay? Questions about that? It's not too bad, right? Yeah.
Can you really put in numbers that are from like 0 to 10, or can be any number?
No, these are just normal ints. So I'm getting an int every time. I could have typed 100, 200, 300. They could be anything. Okay? 4, 5, 6, 7, 8, 9, 10. Our code still works just fine. It's happy. It's just we got space for ints. Okay. Yeah, so we got the sum. What else can we do? With the sum, it's very easy to get the average, right? We can calculate the average very quickly with the sum. So we know there's 10 things in this thing. How do we do that? We got to divide by 10. But I've got an integer and an integer, so that will not give me the right answer, will it? I got to make one of those sides a double. Enter the next element. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And apparently, yeah, that makes sense. The average is 55. Or sum is 55. That means the average is 5.5. Okay. We want to do double division there. All right. We still good? Questions about how I'm using these arrays? So we're filling it up. We made space for it. We fill it up with whatever 10 numbers the user wanted to type. Print them all out, sum them all up, do some cool statistical operations. And then the last one I want to do, I guess, is the minimum. Let's calculate the minimum value in the array. Okay. So here is the algorithm for finding the minimum. It's kind of like sum in that you're going to use an extra variable, but there's some weird things you got to watch out for. Right? So here's the algorithm to check for the minimum. First of all, the minimum value doesn't have to be anywhere special. It could have been anywhere in that array, couldn't it? Like just this one, of course it's in the first index, the way I typed it, but I could have typed 1, 2, -3, right? And now it's suddenly there. That's where the minimum is. I need to find it. Or maybe even I could have typed -10, and now suddenly the minimum is at the end of the array. So the minimum could be anywhere. So with that in mind, we have to visit every single index and see which one might be the minimum, right? Right, so I need to check every index. That's the first thing we noticed. I must check every index because I don't know where the minimum is. I like to abbreviate index as IDX a lot. You'll see that. I have to check every index because the min could be anywhere. I have no guarantee of the order that the user typed the numbers in, right? The min could be anywhere. Okay, and now here's the algorithm. The secret is you're going to have a min variable, and what you're going to do is you're going to just make a guess at the very start. You're going to make a guess that the 0th element really is the min. It might not be the right guess, right? But that's what you're going to do. You're going to guess. Just make a guess, and you're going to keep checking your guess. Guess that the 0th element is the min, is the true min. And that might be wrong, so as you visit everybody else, you will update your guess as necessary. All right, that's going to be the trick. Let's try to walk through that in picture form first. So, all right, to calculate the min of this particular array, I want to visit every index. First, I'm going to pretend that the element at index 0 is the true minimum. So I'm going to place it in my min variable. And then I'm going to look at everybody else. Go to index 1, go to index 2, go to index 3, and keep comparing against my current guess for my minimum. So I see 2. 2 versus 1. 1 still wins. Keep it there. 3 versus 1. 1 still wins. Keep it there. 4 versus 1. 1 still wins. Keep it there. And you'll do that for everybody. And it just turns out that, yeah, it actually was the first element for this exact example. But this algorithm will always work, so it'll find this one as the true min. But what if I made it -3? 1, 2, -3. All those numbers. Again, we'll play the same game. You're going to make the guess that the 0th element is the true min, and you'll update that guess as you visit everybody else. All right, now it's 2 versus 1. Okay, yeah, 1 still wins. Keep it there. Now it's -3 versus 1. -3 is a better guess for the min right now. I'm going to put it there. Does that kind of make sense? And so then we'll compare 4 versus -3. -3 wins. 5 versus -3. -3 still wins. And we'll get through, and like we will have the true minimum by the time we've visited everybody. Yeah, giving them all a chance to become the minimum. Does that kind of make sense? That's what we're going to do. And this will work no matter where it is. Like even if like this is -10 here now, like we've made it -3, 4, 5, 6, don't update the min because it's still smaller than all those. But the second I get to -10, like this was the min before. The second I get to -10, now it's -10 versus -3. And all right, I found something smaller. So like this is the new minimum. I'm going to put it in my min variable. If you let everybody have a chance, the smallest one will win out. Okay, that's hopefully obvious. That's the answer. The devil is in the details that we have to code it up now. So let's try to make this happen. All right. That's the harder one. All right. So what I want to do, I have my R, right? I have indices 0 through 9 for my R. Sum on. That was the other one. I'm going to get the min element. All right. And how do we do it? So I need a min variable to hold my current guess of the min. All right. At the very start, I want to guess that the 0th element is the true minimum. All right. So min starts out being R of 0. All right. That's the algorithm. So guess that R of 0 is the real min. That may be a lie, but it needs a chance. All right. Everybody else needs a chance too. So now I want to look at everybody other than index 0. I don't need to look at index 0 ever again, right? I've already shoved it into min. So for int I equals 1 this time, look at every other index. I is less than 10I plus plus, yeah? Let everybody else have a chance at battling with my current guess for the minimum, all right? So I want to update min if we see a smaller element, right? Just always keep comparing with my current guess for the minimum with the next element that I see. And if I see something smaller, that's a better guess for the minimum, isn't it? So if the value that I'm looking at right now in my array, maybe it's like -3 versus 1 right now. If -3, if I see -3 and my min is 1, then this is true, right? The thing that I see here is smaller. It's a better guess for the minimum, all right? So I will set min to R of I. It's a smaller thing, all right? We're getting closer. It's a better guess, okay? And that's how that works. So let's see, update min if we see a small element. And so yeah, R of I, we just noticed, based on this if statement, is smaller. So it's a better guess for the min. Oh gosh, the min. Yeah, that's kind of the idea. All right, let me zoom out so you can see all that. All right, and then we're playing this game with everybody. Everybody gets a chance at battling for the min spot. And do you kind of see that if you keep playing this game like I was drawing here, the smallest thing will win out. Even if it's like -3, 1. The first guess was 1, then we update it to -3, then we'll update it to -10 because that's even smaller than -3, right? Every time we see something smaller, we're putting it into our min variable. So that means once everybody has had a chance at battling for the minimum spot, we really do have the real min. I have to revisit every element. Min holds the true minimum of our array called R. All right, so see out after all that work, what is our min? It's that, right, whatever that was. Does that make enough sense? This is probably the most complicated algorithm we've learned so far, so it's okay if it's still a little confusing. Definitely stare at it for a moment. Here's just 1 through 10. So the minimum was the first thing; it never got updated. Okay. But if I did 1 to -3, 4, 5, 6, 7, 8, 9, 10, it started at 1. That was our first guess, right? But then we updated it once we were at index 2 to -3 because -3 was smaller than 1. So we updated it there. And that is correct after I got through everybody. Then if I do 1, 2, -3, 4, 5, 6, 7, 8, 9, -10, it's still going to be correct. Right? Start off at 1, update it when we see -3, update it some more once we see -10 because that's even smaller. And so no matter what, if you give everybody a chance, it will find that true minimum. Okay. So I think that's as much as I can say. Any questions about any of that? It's magical, right? We love arrays. So this is some fun code to stare at later. But if we're good, I have one question for you. All right. So let's go to the buy clicker page, and you guys can take bets and convince your neighbors around you that you are right. So please go to that buy clicker page and discuss. Get into a little group, say hi, discuss this question, and also do attendance. I'll stop that once this is over. But here's my question for you. Here's an array. Int blah size 6. And then I try to do this. That's not good, right? What do you think will happen if I were to see out that value? What should happen? Hopefully it's C, right? But what do you think? What's your intuition here? We'll see if your intuition is correct. Give that a try. Think about that. What could it be? What are the values? What would you like this to be? Right? Like this answer. C++ was nice to us. What should happen? Was that enough time? I'll give you like 10 more seconds to answer in your response if you would like it recorded. All right, that's my timer. Let's see what we're thinking. Dun, dun, dun. I promise to stop that. All right, moment of truth, drum roll. Nice. So we think with, I think, a majority. Nice. We're thinking B with the majority, and that would make a whole lot of sense, right? Good job. So yeah, we declare int blah of size 6, blah size 6, blah. So what are its indices? We got what? We got 6 elements. 0, 1, 2, 3, 4, and 5. Yeah? And then I'm trying to shove something into index 7 of blah. Uh-oh. So not only, like that's index 6, not only does that one not exist, this one is even more imaginary over here, index 7, right? Uh-oh. What will happen? Dotted indices because they're not real. So what in the world is going to go here? Right? This is something. Let's figure out what happens. Let's actually code it up. All right. So we're going out of bounds. We're going out of the bounds of this array. That's the technical term. Out of bounds. .cpp. So all right. Int blah size 6. Boop. Blah at 7 equals 42, and then see out whatever that was. Cool. Even my editor is complaining, but it will compile. Ready? Do we take bets? We do see 42 printed, technically, but we also get a runtime error. So yeah, B, technically correct, right? So good. Good those of you who chose B. Very nice. It's going to notice. It's going to notice this time. But let me modify this program a little bit. Let me make some more arrays. Let me make a size 42 character array, and I'm going to sandwich blah. Double array called D with 42 doubles. Now I'm going to compile and run again. 42. No complaints. So the answer was not B. The answer was sometimes B, but not always. Sometimes it will notice that you're messing up. Other times, it'll just do it. It'll just do it, and weird things will happen. It's called undefined behavior. What you're doing is you're accessing memory over here that does not belong to your variable, right? Memory that does not belong to you. Okay? So the answer is, in fact, D. Those of you got that one. Good job. I wish it was C. What happened, the reason it wasn't a runtime error when I added some stuff is that I gave main some extra memory. And so when I went to blah of 7, I was really going to some piece of a double or a couple characters all at once, because 4 characters make an int size worth of things. So I was messing with one of these. It depends which one. Depends on the compiler and the operating system. But by doing this, I messed with memory that wasn't part of what I wanted to mess with. I messed with another variable, and that's going to lead to really, really weird bugs. Okay? So hopefully, this is an interesting example, and you will remember to never make this mistake. But it happens. Sometimes it'll just work, which is unfortunate for CSCI 40 students. Then it's really hard to track that bug down. Right? So always be extra vigilant, constant vigilance, as you're trying to go to an index of an array. All right? Any questions about this example? It's a fun one. All right, now we know. Now we know. So yeah, it's called undefined behavior. That's the magic of it all. So you can technically go somewhere. You can go to R of 5 when it's size 5 and it only goes up to 4. All right? You can technically do it, but you should never, ever do that unless you're trying to like hack something. That's like a common bug that people use to exploit things, actually. So you should never do that, even though it might work. And honestly, if you have enough variables declared, it will probably work. But you can't bank on that, all right? The second you do, you invoke the wrath of undefined behavior. Somebody, like a bunch of smart people got in a room, and they wrote down exactly what should happen every time you write code in C++. They said, okay, this is what this line does. This is what this kind of assignment statement does. They left some things blank, like when you do something dumb like this, they called it undefined behavior. It's not defined in the standard. And so anybody who goes and makes a C++ compiler is allowed to do whatever it wants if it notices the rules of C++, and the compiler is allowed to do whatever it wants with your code. It's technically correct with respect to the C++ language standard for your program as it runs to, like, the compiler could just put in code that deletes every file on your computer. That's technically valid according to the specification. It could replace those files with cat pictures if it wanted to. Technically correct if you go outside of the bounds of an array. So try not to, right? That is the goal, and that is the warning. All right. Any questions about any of that? So we learned a bit about arrays right now. We good with those? We got a lot of examples to study, fun things. But if we're happy, that's why I want to stop with that set of slides, and we'll come back next time. All right. But we're not done yet because I got plenty more things to talk about. We've got a lab. All right. I'm going to give you a new lab, and this one I will give you several weeks to complete, because you'll be studying, hopefully, you'll be studying for the midterm that I will also be talking about. Okay, so here's lab 3. Let's look at it together. This one is about loops, specifically nested loops. Those are the ones you really got to practice. 4003. All right, I've got 2 files for you. One for triangles, one for a graphing calculator. All right, so here we go. Got those files. The first step, the first program I want you to write is the drawtriangle.cpp file. So you'll compile it in the way that you know how, and here's how I want you to run it. So you're going to ask the user for a size, and you're going to use that size to draw a right-leaning right triangle. So if they enter 5, you're going to draw a triangle that looks just like this. You see how there's 5 rows, there's 5 lines. It's 5 wide at the bottom. Okay, but I did the left-leaning one in class. You're going to do a right-leaning one for your left. Right? So you got to move over to get to that position with a space character a bunch of times. A bunch of spaces and then a star. A bunch of spaces and then 2 stars. Okay? That's what you'll be doing. So a size 8 triangle should look like this. It's got 8 lines, so 8 with 8 at the bottom, but you start out like that. Right? Spaces and then stars. That makes sense? That's what you're going to do. I've done some of it. I've got the size prompt going. What else? Yeah. Print a right-leaning right triangle, and I've got a little hint line for you. That will help you, hopefully. And then there's one more thing. So size 2, that's a valid triangle. Size 1 is technically a valid triangle. Still do it. Size 0 or smaller, if the user gives you a bad size, like the triangle is impossible. 0. Technically 0 is possible. It's just a blank triangle, no lines. Anything smaller than 0 is impossible, right? It makes no sense to draw a -1 size triangle. So if the user ever gives you a negative value, what I'd like you to do is keep this line that prints out invalid size, but don't let it fall through to your normal print a triangle code, because it might like mess with your loop in a weird way. It might like make it an infinite loop or something. So what I want you to do, if the size is ever invalid, like it's -1, -2, I want you to stop the program. Okay? Stop the program here. Don't let it get down here. So there's 2 ways to stop the program. One way is to say return 0 up here, or return 1. You can give like an invalid exit code if you'd like, because it's like an invalid run of the program. That's technically okay. There's also the exit function in cstdlib, if you remember that. Either one will work. Don't let the program continue after this body though. Okay, so that is your triangle program. Compile it and run it as you know how to do. Okay, questions about that part of your lab? All right, for the final part, I am excited to do the graphing calculator. So you got graphingcalc.cpp, and I have given you most of the code. I've given you the nested loop already, just like I did in class. Your job is just to do the right if statements, like I was kind of doing, to print out the graph in a pretty way. Okay, so here's the goal. I need to like zoom out to show you everything. Sorry, but the user is going to enter in which graph they want drawn. All right, they're going to enter in 0, 1, or 2 as their choice for which graph they want. And so if they type in 0, you're gonna produce this graph, this parabola. If they type in option 1, they want option 1, you're gonna give this cubic function. And if they type option 2, you're gonna give this sine function. Right? That's what you're gonna graph y equals those things. Just one though. So based on that choice, you're gonna have to use that when you graph. Right? So I've given you the nested loop. It's just your job to do the graphing. All right. So here's how it should look. If the user types option 0, that's you. This should be how you graph this exact function, right? So you got to do the rounding, do all the special stuff like I was talking about in class. You don't have to solve for y. I've already solved for y for you. But this should be how this one looks, right? So you're going to draw a line, or draw stars for the graph, if it's on the graph. One y per x. And then also, you're going to draw the axes. Dashes for the x-axis, pipe characters for the y-axis, and then the axes meeting can be the plus still. So that'll be really cute. It's really, really nice. Very, very fulfilling to get this. It feels nice when you get it working, I promise. So that's that one. The other one, option 1, is this cubic function. It should look like this, just like that. And then finally, option 2, the sine wave, should look like this. The star overrides the plus of the axis meeting. Okay, that one takes precedence. So that'll help you, hopefully, when you order your if statements. So yeah, that's how it needs to look. Use that as your guide, and use the code that I'm giving you from class, of course, as your guide. This is going to take a while, and that's why I'm giving you multiple weeks, in addition to there being a midterm. Okay? So yeah, please just read the whole thing. I've given you a bunch of helpful comments. You got to use round, check and see if it's all going to work out. Just read everything. That should be very helpful. But yeah, if your current XY coordinate pair, and remember that you're ranging through them all, right? You got a current coordinate right now. If your XY pair is on the current graph for the user's choice that they chose, you better print a star. That takes precedence over everything else. And then otherwise, all right, if you weren't on the graph, then you still might need to print like an axis or something. So if x was 0, you're on the y-axis, print the pipe. If y is 0, then you're on the x-axis, print a dash. But if they're both 0, we'll have to reorder that, right? Then it's the plus. You want to show the meeting, all right? If you're not on an axis and you're not on the graph, then you still need to move the cursor over so that next round of the loop, you're ready to do the next thing. It might be on the graph over there. So you need to print a space, right? Just like I was doing. If none of that's true, print a space to just move you over, get you on the next column. Okay? So that is what you want to do. And after each set of x's, you're ready for new y's. So you got to shift it down with a new line. So just follow my comments. It shouldn't be too bad. It'll take some staring at my code from class, though, that's for sure. Okay? Start early and ask lots of questions. But I think that's as much as I can explain it. Are there any questions about this code at this part of your lab? It's going to look really pretty. It's very, very, very nice, very satisfying to get it working. All right, so this will be due week 7, so after the midterm. But you'll turn in those 2 files that you worked on, and that'll be done. So you got plenty of time to do it. And if we're good, it's time to talk about the midterm. All right, so we are in week 4. And I promise that our first exam, our first midterm, will be during week 6. So it's 2 weeks away. And I will now be releasing this little midterm 1 module on Canvas. Right? I'll release the info page and the extra credit assignment page. Okay? So you should be able to see that now. Let's go to both of those. All right, here is your information about the midterm. So the midterm is going to be the latest possible day we could have it on week 6. It'll be on the Thursday of week 6. So that's September 19th, 2 weeks away. Boop, boop. So right there. And you'll get the first hour and a half of class to take the exam. Okay? So get here on time. Because once you click start on the test, it's going to have a little timer that starts counting down. You're going to only get an hour and a half to take it. Okay? So keep that in mind. Yeah, I think that's what I wanted to say there. So that's the logistics. That's when it's going to be. Here's what it's going to be on. Just read all these lists. So lectures up to week 5, not including functions. Arrays and vectors, the things that I started talking about today, will be the last potential topic that you might see. These iBook readings, Xylabs, and labs 0 through 3. So that includes this one today. Even though it's due after the test, you should do it. Because I'm going to definitely be asking loop questions. And that is a lab that goes over loops. All right, it's a totally fair game for me to ask about lab 3 stuff. And then here's just a list of topics written out. I know arrays and vectors will be the closest thing to the midterm, so I don't want to hit you too hard with those questions. So I promise that if I ask you anything about arrays and vectors on the test, it will be an easy question.
That's the one to do next week.
It's due week 7, not next week. I said week 7. Okay, yeah. And then here's the format of the test. It will have the following. It's going to be on Canvas. So you're just going to go here. This will be available for you to click and start it. It'll be a little quiz on Canvas, but it's really a test. And once you get to the page, you'll have little blanks. You'll have fill in the blank questions, so you'll type in answers. And then there's also coding questions. So you're going to put C++ into Canvas. You're going to paste it into a Canvas text box. So I want you to prepare for that, all right? I don't know if you've tried yet. Do you know how to copy and paste out of PuTTY? Or whatever terminal you're using? Figure that out, okay? Don't be learning it on the test, because that's going to waste time. It's going to waste a lot of time. So figure that out before the test, please. Yeah, and then finally, the test is open book and open notes, so good news for you. The only thing you can't do is talk to a human other than me as you're taking it, or to AI, or something obvious like that, okay? So, yeah. You're allowed to use your notes and all the code that I wrote in class, and all the labs you've ever done. You can be on the class server, of course, as you're taking the test. Those are all the rules. And then here's a sample midterm from last time. Use that to study. Yeah, I think that's all the information that I can possibly give you about the midterm. Are there any questions about it? With every exam in the class, I like to give an extra credit opportunity. So if you would like to, please make a review video for midterm ones. This is like me forcing you to study, and then also your peers are going to love you forever because like you'll be posting it and they can see it too. So even if you don't do the extra credit assignment, like come to this page because you'll see other people, and that'll help you study for the test. So this is worth up to 2.5% extra credit on your final grade. So because this is not a normal assignment, it's going to be due. It's the only kinds of assignments in this class that's due at midnight for everybody. This is going to be due the midnight before the test. So test comes out on September 19th. So this will be due midnight on the 18th, 11:59. Okay. There are no extensions apply, no late submissions. If you are a minute late, you don't get credit. All right. So just keep that in mind. Get it uploaded ahead of time. It's extra. All right. So here are your requirements if you'd like to do it. Make a little review video where you like go over stuff that's going to be on the exam. Shouldn't be too bad, right? You can just post a raw video. I'm not editing these lectures that I give you, so like you can do the same thing, okay? And you'll give like a little public link, like you put it on YouTube or something, and you can post the link, or I think you can even upload the video itself to Canvas, whatever you want to do. So that's how you can submit it. And then yeah, here are your hard requirements. All right, so naturally, if you're reviewing, you have to give a bunch of examples. So create some examples out of your brain about things that might appear on the exam, and you'll use those and like pretend to be a teacher, maybe. Pretend to be me, giving a little lecture, go through all the things, your examples, demonstrate how to solve them, explain all the things that you're doing, all right? Just like be useful, be helpful to your fellow peers and to yourself. Yeah, pretty straightforward, I hope. If you want just half the percentage of the extra credit, make at least a 10-minute video going over a bunch of stuff. If you want the full 2.5%, please make a 20-minute video at least going over stuff. All right. So hopefully those requirements make enough sense. Yell at me if they do not. The last thing I want to say, I shouldn't have to, but I have to say it anyway. So you have to make something new. Extra credit means you're doing extra work. Okay. You have to make something brand new for you to get credit. All right. You have to write brand new code out of your brain. Create brand new slides that you didn't steal off the internet. Right? Draw a brand new diagram, something like that. Okay. So just keep that in mind. It is not enough to just read off my slides. That is lazy. That is not extra. Okay, it's not enough to read and go over a lab that you already did. That's not extra. All right. So I am the final judge of whether you did enough extra work to receive the extra credit. So if you are at all confused about whether what you're planning on doing is enough, talk to me first so that I don't give you a 0. Okay. I want you to get the credit if you want it. So check with me if you're at all confused or concerned. But yeah, that is my last requirement. If you're wondering about how to record yourself, like this is a program that Twitch streamers like to use. It's called OBS. It's a fun one. It's useful. I use that in class. There's also Zoom. Like I think we all have Zoom installed probably. You can like start up a private meeting for yourself in Zoom, and there should be a record to my computer button. So that's also a possibility. And yeah, let me know if you need any help like getting that working. And remember that the library is going to like check you out a laptop if you need that for the extra credit. So I want to make sure that anybody who wants to do it can do it. So talk to me if you have any concerns or anything like that. But I think that is all that I wanted to say. Please take advantage of this if you would like to. Questions about that? All right. I think I don't have to say any more words today. I think that's everything that I wanted to talk about. All right. So yeah. The rest of the time is all yours.